Good morning, students. The last class we discussed about that ionic radius. Now we are going to talk about ionization energy. Ionization energy. You see, ionization energy, or it may be also called as ionization enthalpy. Ionization enthalpy and also ionization potential. Ionization potential. You see, the ionization, before talking ionization, the ionization is nothing but the energy, the energy required to remove the electrons from isolated gaseous, okay, from outermost shell. You see, to remove, you see, this is a nucleus, this is the shells. To remove the outermost electrons, we need some energy, okay, that is nothing but ionization energy. Okay, first we defined it, or definition. The amount of energy required to remove outermost, see, the energy required to remove outermost electron from an isolated gaseous neutral atom. I said it is outermost electrons. Okay, outermost electrons. For example, you take an atom, must be in gaseous state. Ionization energy it used only in gaseous state atoms. Okay, the gaseous state atom, I taken that A is atom. I given to that ionization energy IE to the atom, it removes the outermost electron. If it removes, what happens? It becomes A plus, correct? No, it removes the electrons. Okay, that we call as delta H. Okay, delta H may be, you see, one is positive charge, one is negative charge. When will the positive charge energy absorbed? If energy is absorbed, okay, see, the energy is absorbed, that time it must be a positive charges. Then it will be, or every time ionization energy delta H is positive charge only, positive charge. Okay, well, negative, if for some cases energy is released, okay, it is exothermic reactions. Only in exothermic reactions enthalpy is positive, ionization energy will be negative, ionization will be negative. If endothermic reactions, ionization energy will be positive. Well, ionization energy will be negative when the energy will be released. Okay, the units units for ionization energy kilojoules per mole, or another one is electron volt per atom. Electron volt per atom, 1 electron volt per atom is equals to 96.42 joule per mole. Okay, see, consider if you take any metal, for example, I will take metal, that is M, metal in gaseous state. Okay, metal in gaseous state, we use ionization energy. Okay, ionization energy, that time metal became positive, it leaves electrons. Okay, for that it become positive, we call unique positive, it is unique positive ions, we call it is a unique positive ion. Or will come to this ionization, we called ionization E1 because it is first ionization energy, correct? No, first ionization energy. Again if we remove another electron from the positive metal, that is M plus, if we again gaseous state, if we again give the ionization energy, it gives M2 plus, it gives another electron, correct? No, this IE called ionization energy, second ionization energy. You see, the second ionization energy is greater than first ionization energy, because you see, in first ionization energy, electrons are removed from the neutral, because it is in neutral state. No, it is in neutral atom, we are removing electron from the neutral atom easily. But when come to second ionization energy, we are removing the electron from the positive ion. Okay, for electron be the less in the number of protons. Okay, I will tell that why ionization energy 2 is greater than ionization energy 1. Why? Because ionization energy in first, electrons removed from parent atom or neutral atom. When come to ionization energy 2, electrons are removed from the positive ion. Okay, do you understand this ionization energy? Okay, next if we want to give another reason, this is a one reason. If you want to give the another reason, you see, the electrons will be less in number of protons when compared to more positive nucleus increases. Okay, we will talk another variation of ionization energy in periodical table. Variations in ionization periodical table. If you take a periodical table, this is period, this is group. Okay, first we are going to talk about groups. What happens in periodical table? You see, in groups from top to bottom in periodical table, the ionization energy decreases. It will be decreases. Then come to here, it will be increases. Okay, in groups, ionization energy decreases. Why it decreases? Because we move top to bottom in the group, the atomic size it will be increases, correct? No, it will be increase, atomic size will be increases. Then addition of electron electron shell distance between the nucleus and valency of electrons increases. You see, in the atomic size, when to top to bottom, what happens? You see, this is a nucleus, atomic size increases, correct? No, atomic size increases. If increases, nucleus to valency shell, the electrons, the distance between the nucleus and valency electrons will be increases. If increases, then nuclear force of attraction will be decreases. Nuclear charges are nuclear force of attraction. Force of attraction decreases. For example, you take lithium, sodium, potassium, rubidium, cesium. Okay, you take for lithium is 1s2 2s1, correct? No, it's having 1s 2s. When come to sodium, if we talk, sodium is 11, 1s2 2s2 2p 6 3s1, correct? No, one orbital, second orbital, third orbital. You see, the atomic size is increases. This increases, the inner electrons will produces. Okay, this increases inner electron will protect the valency electrons. See, increases the inner electrons. If it increases the inner electrons, it protects the valency electrons. Inner electrons means, for example, these electrons will protect the valence electrons, which we call it as shielding effect, or also called protective effect. Why we call shielding effect? Because increasing inner electrons will protect the valency electrons. We call it as shielding effect. Okay, we talk on the groups. Now we are going to talk about periods. Already I told that ionization energy will be increases. Why it increases? We take a third period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen. Because from left to right side of the periodical table, atomic size decreases. You see what happens here? It is opposite. Atomic size decreases. Then nuclear force of attraction increases. Okay, the atomic number increases, the nuclear charges will be increases, atomic radius decreases, it is to close to the nucleus. Now factors affecting ionization energy. Factors affecting ionization energy. First factor, atomic size or atomic radius. Okay. Second, nuclear charges. Nuclear charge. Third, shielding. I already told you what is shielding. Shielding effect. Fourth one, electronic configuration. Fifth, removal of electrons from the orbitals. Removal of electrons from orbitals, that is s, p, d, f orbitals. These are factors affecting the ionization energy. Okay. Next we are going to talk that in the first atomic size based on the ionization energy. Okay. Atomic size of the atom will be decayed the distance of the valence of electrons from the nucleus. We know that first of all the ionization energy is inversely proportional to atomic size. If ionization energy increases, then atomic size must be decreases, because the attraction between the nucleus and electrons decreases, okay, with increasing the atomic size. Attraction between the nucleus and electron, valency shell electron or electrons decreases with the increasing atomic size. Correct? No? If atomic size increasing, what will be the distance between the attraction between the nucleus and the electrons will be decreases. If atomic size is smaller, then the attraction will be more. Okay. Second, we talk on that atomic size. Next we are going to talk about electronic configuration. See, electronic configuration, it based on two types, that is you see, half-filled orbitals, completely filled orbitals. Half-filled or completely filled, it shows extra stability. Sir, how can you tell that half filled or completely filled shows the extra stability? You see, for example, I am taking nitrogen is atomic number 7, its electronic configuration 1s2, 2s2, 2p3. If p orbitals, if you write px, py, pz, correct? No? See, in p orbitals the 3 half filled, it's half filled, correct? No? When come to beryllium, if electronic configuration is 2, then 1s2 is completely filled. For example, I am taking that. Okay, for example, I am taking that is completely filled. You see, sodium and beryllium is ionizations. Sorry, nitrogens. I am not a sodium. Nitrogens and beryllium is ionization energy in the in the periodical table because because of filled and completely filled. Okay, next point, what we told, that factors affecting atomic size and electronic configuration. Another one is removal of electrons from the orbitals, correct? No, removal of electrons from different orbitals like s, p, d, f. You see, the nuclear force of attraction is more in s. Why, sir, it is more in s? You will have no doubt, because for that it is nucleus, s orbital, p orbital, d orbital, f orbital. S, P, D, F. You see, when come to nucleus near, it is S, correct? No, then it has the nuclear force of attraction is more in S. I am taking here, it is a nucleus. S is more compared to P. P is more compared to D. D is more is compared to F. Means nuclear force of attraction is more in S compared to P and DF. When I'll write that nuclear force of attraction is more in S compared to PDF. When you talk nuclear force of attraction is more compared to P and D. P is more. Okay, the nuclear force will be maximum and minimum. Okay, next we are going to talk about shielding effect. Already I told what is shielding effect. Okay, now we are going to deep shielding effect. Shielding effect or protective effect or screening effect. See, I will write the atom. Okay. These are the electrons, outer shell electrons. Okay, this is a inner shell electrons. Quite common, it is nucleus. The electrons present in the inner shell, these electrons will try to protect the outer shell of the electrons from the nuclear force of attraction. Means attracting, it will be protected. No, the inner will be protecting the outermost by the attraction forces between nucleus and outermost electrons. It called shielding effect. Inner electrons attracted by the nucleus, there is a repulsion between inner and outer. You see, here also electrons are there, here also electrons are there. Here the repulsions are occurring. If it attracts the electrons, what happen? These electrons will be, repulsion will be started. because like charges will be repel, unlike charges will be attracts. Okay, the inner electrons large is no shielding effect. Okay, I will write it what I told. The electrons present in the inner shell electrons, this inner electrons, it will try to protect the outer shell electrons from the nuclear force of attraction is called shielding effect or screening effect. The inner electrons attracted by the nucleus, inner electrons will be attracted. The inner electrons are attracted by the nucleus. This is repulsion between inner, there is a, we'll write there is repulsion between inner electron and outer electrons, because both have same charges, negative charges. Okay, if inner electron charges larger is no shielding. If you see, if inner electrons larger, if inner electron charge is inner electron larger, then no, it shows the number of shielding, because the more electrons is there in the inner, it will be protects the outermost, then number of shielding effect increases. When will be the shielding effect is more? When will be the shielding effect is more? When the inner electrons are more or larger. Okay, this shows that shielding effect. Okay.